An exponential equation has a variable in its exponent. These are all examples of exponential equations. The approach we take to solving the equation will depend upon what we notice about the bases in the equation. So let's see how we can solve these 5 exponential equations. The first equation has an exponential expression on the left side with a base of 10. The important thing to notice here is that the 100 on the right side isn't an exponential expression, but we can rewrite it as an exponential expression that also has a base of 10. Since these two exponential expressions have the same base and they're equal to each other, we know that the exponents have to also be equal to each other. And that allows us to solve the equation x minus 2 equals 2, so x equals 4. Our next exponential equation has exponential expressions on both sides of the equal sign. The bases 4 and 8 are different, but we can rewrite each of those bases as a power of 2. So 4 is 2 squared, and 8 is 2 to the third power. Now we'll use a property of exponents. Since we have a power to a power, all we have to do is multiply the powers. Now we've got two exponential expressions that are equal to each other, and they have the same base. So the exponents have to be equal to each other. We can subtract 3x from both sides, subtract 2 from both sides, and multiply both sides by -1 to get our solution of x equals 5. Our next example is a little more complicated because we can't make the base on the left, the 10, equal to the base on the right, the 4. 4 is 2 squared, but we can't rewrite 10 as 2 to a power. So we're going to rely on some properties of logarithms to get to our solution. Since we need to get that variable out of the exponent in order to solve the equation, we'll use this property of logarithms. It says that if we have a log of any base of m to the n power, we can rewrite that by bringing the n out front as a factor times the log of m. So our next step in solving is going to be to take the log of both sides of the equation. The question is, what base do we use on our log? We're going to choose to use a base 10 because the base on our exponential expression is a 10. Now we could write that log as a log base 10, but if we just write log, the base is implied to be a 10. So we'll take the log of both sides of the equation. That allows us to take that 3x in the exponent and bring it down front and multiply it times the log of 10. That log of 10 is interesting because we can deal with that using this property of logs. The log base b of b is 1. Remember, the base on our log is 10, and we have the log base 10 of 10 right here as a factor. That's equal to 1. So 3x times 1 is just 3x. If we multiply both sides of the equation by 1/3, we'll have our answer. X equals 1/3 times the log of 4. In our next example, our exponential expression has a base of e. We'll be taking a log of both sides of the equation to bring that 4x out of the exponent, but we have to choose a base. And we're going to take our cue from the fact that the base is e on that exponential expression. So the log that we'll be using is a log with a base of e. In other words, a natural log. So we'll take the natural log of both sides of the equation. That allows us to bring the 4x down in front and multiply it times the natural log of e. Remembering that the natural log of e is really just a log with a base of e allows us to replace the natural log of e with a 1, and 4x times 1 is 4x. Now we'll multiply both sides times 1/4 to get our answer. X equals 1/4 times the natural log of 7. We've seen that if the base on our exponential expression is 10, we can use a common log of both sides of the equation. And if the base on the exponential expression is an e, we can use a natural log of both sides. But what do we do if the base is a 5? Well, we could just take the log base 5 of both sides of the equation. On the left side, that exponent can come down front as a factor, but now we have to look at that log base 5 of 5. That's equal to 1. So 1 times x minus 3 is x minus 3. Add 3 to both sides of the equation, and we've got our solution. X equals 3 plus the log base 5 of 2. Now we chose to take a log base 5 of both sides of the equation because our exponential expression had a base of 5. But that's not the only way we could have solved this equation. We can take the log of any base of both sides of the equation. So maybe we'd decide we want to take a natural log of both sides. That's perfectly all right. We'll do the same steps, bring that x minus 3 down front, but now the difference is that natural log of 5 we can't rewrite as a 1. But it is a number, and we can certainly choose to divide both sides of the equation by the natural log of 5. And then if we add 3 to both sides of the equation, we've got our answer. X equals 3 plus the natural log of 2 divided by the natural log of 5. That may look a little different than our first answer, but they are equivalent. They have exactly the same value.